Good morning, Miss Kelsey.
Good morning.
Good morning, Evan.
Good morning.
Surely everybody needs to be here since I didn't have a section 5.5 video in YouTube. I tell you what, while we're waiting on them, do one thing for me. Draw the Cartesian coordinate system and on a unit circle, label these 4 points. Label, excuse me, label them with their degree measure and their ordered pair. I think I said degree measure, I meant radian measure. Do their radian measure in the ordered pair. Is that what you have?
More or less.
Yes.
Okay, all right. In section 5.5, we're going to graph cosine and sine, and then in 5.6, we're going to graph the other 4 trigonometric functions. But we're just going to talk about cosine and sine today, and I do have the 5.6 video in Momentum, so you'll be able to watch it before tomorrow. The thing that used to confuse me 30 years ago, gosh, maybe 40 now, when I first learned trig, it just kept getting messed up in my head looking at the equation y equals cosine x and thinking cosine x is the x coordinate. So what does y equals x mean? If that sounds convoluted, it's because it was convoluted in my head at the time. So I'm going to try to make that more clear to you than it was to me at the time. The x that is your independent variable, you give me an x, I'm going to give you a y. That x can be any angle. What's the domain of cosine? What numbers can you take the cosine of? And sine also, for that matter. Trying to think if we have mentioned that before. By your quietness, I'm thinking maybe not. You can take the cosine of anything from negative infinity to infinity. There is nothing that you can have on your calculator and hit your cosine button that you get an error. So the domain of both cosine and sine is negative infinity to infinity, because we can go around the circle infinitely many times in degrees or in radians. You give me a degree or a radian measure of an angle, I can find that angle on the Cartesian coordinate system or on the unit circle, and then I can get the ordered pair at that point on the unit circle, and cosine is just the x coordinate of the ordered pair, sine is just the y coordinate of the ordered pair. So just like anytime we graph something for the first time, I'm going to assume I have no idea what it looks like. I'm going to choose some values of x that are in the domain. So for cosine x. I can let x be anything. I'm gonna be lazy instead of pick my -1, 0, and 1 that I usually do with linear equations. I'm gonna choose multiples of pi over 2. I don't know what the cosine of 1 is. I don't know what the cosine of 2 is, but I know what the cosine of 0 is, and I know what the cosine of pi over 2 is, and pi and 3/2 pi and 2 pi. So when I say when x is 0, what is y? Y is the x coordinate of the ordered pair. This is the x coordinate of the ordered pair at x radians. You could also use x degrees, but if no degree symbol is there, then I'm going to take that to be radians. When I'm graphing y equals sine x, I'm thinking sine x is the y coordinate of the ordered pair at x radians. Excuse me. That's not coronavirus, that's something tickling my throat. And if it doesn't stop, I'm going to go get a drink of water. Okay. So in both of these cases, x is a radian measure of an angle, and cosine of x is the x coordinate of the ordered pair at x radians. Sine of x is the y coordinate of the ordered pair at x radians. I have already made you a sine, XY chart for both cosine and sine, just to have there to refer to later. But as we go around the circle and I name an angle in radians, when I say at 0 radians, what is y? I'm asking you for the x coordinate at 0 radians. So at 0 radians, what is cosine 0? Cosine of 0 radians. Look at your ordered pair that you just drew.
Is it 1?
Yeah, it's the x coordinate at 0 radians, and the x coordinate at 0 radians is 1. So the point 0, 1 is on the graph of y equals cosine x. And at pi over 2, what is the x coordinate of the ordered pair? Evan, it's your turn. At pi over 2, what is the x coordinate?
Give me a second. I'm looking at my.
I'm sorry, I didn't understand you. What?
Give me a hot second.
You were still a little bit fuzzy. It sounded like you said, give me a second.
Yeah, my notes are all kinds of everywhere.
Well, look at my picture right here. You don't have to have your own. At pi over 2 radians, I have pi over 2 radians labeled. What is the x coordinate of the ordered pair at pi over 2 radians?
Yeah, I was misunderstanding you. Oh, that's
okay.
just 0.
It's because a lot of times I don't say something well the first time. So what is it?
That'd be 0.
Correct. And I just forgot my other person. Evan and, was that Autumn?
Kelsey.
Okay. Kelsey. Kelsey, at pi radians, what's the x coordinate?
-1.
Yep. And Evan, at 3/2 pi, what's the x coordinate?
0 again.
Yeah, you got the easy one. Yours is always 0. And 2 pi, Miss Kelsey, what is the x coordinate at 2 pi?
1.
At 1. And then we could go around the circle infinitely many times and extend that graph on to eternity. Also, we could go backwards around the circle, backwards being clockwise, and say at negative pi over 2. Negative pi over 2 is the same thing as 3/2 pi. Y is 0. As a matter of fact, when I said the answer to all of Evan's questions are 0, that's because at all the half pi's, x is 0. So all the half pi's are your x-intercepts. And then at negative pi, cosine, or the x-coordinate, is -1. And all the way around to negative 2 pi, the x-coordinate's back to +1. So if we connect those dots, we have a pretty good picture of the graph of cosine. And actually, that's called 2 periods of the graph of cosine, because 1 period of a trigonometric function is the interval that it takes for the function to do everything it's going to do, from +1 to -1 back to +1. So if I just ask you to graph 1 period of cosine, I could use this for 1 period of cosine. All the way from 0 to 2 pi would give me a picture of everything that cosine is ever going to do. Does that make sense?
Yeah.
Miss Kelsey?
Yes.
Okie doke. So we could say 1 period of cosine is from, for all x's between 0 and 2 pi. I could include those endpoints or just one of the endpoints if I only wanted to have +1 happen once. There's another word you need to know about the graphs of trigonometric functions, and that's amplitude. The amplitude is the absolute value. It's the height of the graph from this center line. The center line on the graph we just drew is just the x-axis. It cuts straight through the middle, and this graph goes one above the x-axis and one below the x-axis, so its amplitude is 1. Just how high the graph goes above or below the x-axis. And that's the 3 main things you need to know about the graph of cosine right now. Let's do the same thing for sine. I'm going to say, what's the sine at 0 radians? And you give me the y-coordinate at 0 radians. And Ms. Kelsey, you'll get the easy ones this time. What is sine of 0 radians?
0.
All right. Evan, what's the sine of half pi radians?
1.
Yep. And Miss Kelsey's going to get tired of answering and saying, at all the whole pi's, y would be 0. Sine is 0 at all the whole pi's. So I'm going to go ahead and label all of my whole pi's as the x-intercepts. And then for my half pi's, sine keeps going +1, -1, +1, -1, +1, -1. So Evan told me at pi over 2, the y-coordinate's +1. At 3/2 pi, the y-coordinate will be down to -1. At negative pi over 2, negative pi over 2 is the same as 3/2 pi because we're just going backwards. What is sine? The y-coordinate of the ordered pair at negative pi over 2 is what?
-1.
All right. So negative pi over 2 is -1. Negative 3/2 pi is going to be back up to +1. And we can graph or plot those points, connect those points is what I'm trying to say. And we have a pretty good graph of sine x, which looks a whole lot like the graph of cosine x, except for it's been shifted over pi over 2 radians. I'll say more about that later. For right now, just let me say, if I wanted 1 period of the graph of sine, I could use the same 0 to 2 pi that I use for cosine. For 1 period, I could still use 0 is less than or equal to x is less than 2 pi without including this endpoint twice. I could say the amplitude of the graph of sine is still 1. Now notice if we use 0 for the left endpoint and 2 pi for the right endpoint of one graph of each of those functions, cosine kind of looks, well, if I cut off the ends, it would kind of look like a parabola. It's kind of U-shaped, only it doesn't keep going up, it turns and comes back down. So when you say cosine, that's the image I have in my head for 1 period. When you say sine for 1 period, that's the image I have in my head. And my math lab has tools for graphing sine and cosine. I was glad that all the problems in tonight's homework didn't just have to be multiple choice graphs. When you're graphing sine, you want to choose the wave that looks like this. And when you're graphing cosine, you want to choose the wave that looks like this. And then you have to enter some other information, and my math lab will do the graph for you. After you choose either sine or cosine, you enter the amplitude that will affect the height of the graph. You enter the period, which affects how long it takes a graph to do one whole thing. And then we'll talk about vertical shifts, phase shifts, and reflections in a minute. All right, to sum up what we know about the graph of sine and cosine, and then we'll do some examples. On the back of the notes, I've put really everything you need to know about sine and the graphs of sine and cosine. Where was sine 0? Where did it have its x-intercepts? Is that whole pi's or half pi's where your y-coordinate is 0?
Whole pies.
Yes. So at the whole pi's, I'm just going to go ahead and plot my x-intercepts, and we're only going to graph 1 period here. So I'm just going to graph these 3 x-intercepts and then say pi over 2, I know sine is +1, 3/2 pi is -1, and that's good enough if I just need 1 period of sine. So for that 1 period, I'm going to say the endpoints are at 0, 0, and at 2 pi, 0. And the midpoint, halfway between 0 and 2 pi, is 1 pi, and sine of pi is 0. Now, just like we can shift other graphs of polynomial functions or transcendental functions, we can shift them by adding or subtracting something to or from the x before you apply the function, or adding and subtracting something after you've applied the function. We're going to say that same thing here about sine functions in a minute, to find how this graph has been shifted horizontally. By the way, that's called your phase shift. To find your phase shift, we're just going to set the argument, the bx plus c, whatever it is, between the normal endpoints of sine, which are at 0 and 2 pi. And like I said, I normally don't even use the word phase shift in class because we're graphing these by hand, and I talk about it a little bit differently when I'm graphing it by hand. But since my math lab is going to ask you to enter the phase shift, you need to know that this is how you get it. What I say when we're not graphing on my math lab is to find one period of the graph. You set that argument between 0 and 2 pi. Now, the graph of y equals sine x, like we said, it has an amplitude of 1 and a period of 2 pi. Let's do the same thing for cosine, just summarize it right here, and then we will talk about what changes the amplitude or period of a graph. Where did cosine have its x-intercepts? Where was the x-coordinate 0? At the half pies or the whole pies?
Half pies.
So if I'm only going to graph one period, I'll put my x-intercepts at the half pies. And I know at 0, cosine is 1. At pi, cosine is -1. At 2 pi, cosine is back to 1. So over that period from 0 to 2 pi, remember cosine looks more like a U. Its amplitude is 1. Its period is 1. The endpoints of one period are still at 0 and 2 pi. Those are the x coordinates of the endpoints, but the y coordinates of the endpoints are 1 and then the midpoint is at pi -1. And to find one period of the graph of cosine that's been shifted somehow, and that's called the phase shift, you're just going to set that argument between 0 and 2 pi and solve for x. That'll give you the phase shift.
Can you repeat that again about the phase shift?
Yes. Actually, I realized I didn't say it just like I wanted to say it. Let me go back to saying, to find one period of the graph, you set the argument between its normal endpoints. And I'm talking about the x coordinates of its endpoint, 0 and 2 pi. When we're graphing it by hand, that's how we find one period of the graph. To find the phase shift, you just set bx plus c equal to 0. That's true in both cases. Whatever bx plus c is, whatever the argument is, you set that equal to 0, and that will give you the phase shift that you're going to enter on the calculator or in my math lab. Was that better, Kelsey?
Yes, can you do an example of it first?
Absolutely. No, I'm not going to do any examples. I'm just going to talk for a while and turn you loose. No, I will definitely do examples. I just wanted you to have that written down before we started the examples. After you see
Alrighty.
it, it'll make a lot more sense.
Okay, thank you.
No problem. So we've talked about, or at least written down, even though we've not illustrated yet, how we find the phase shift. Let's go back up to the top of this page for just a minute and talk about what changes the amplitude and a period of the graph. The amplitude can be affected or is affected by the coefficient on the trig function. And the period of the graph is affected by the coefficient of the x within the trig function. So in the A part, the graph of 4 cosine x has a period of 4 instead of a period of 1, because that's the coefficient of the trig function. Now, wait, I think I said something wrong. The amplitude in the A part is 4 instead of 1. 1 is the normal amplitude of the trig function. The amplitude of this one's 4. What's the normal period of cosine? How big of an interval does it take for cosine to do its whole thing?
0 to 2 pi.
2 pi. So we want our graph to look the same shape as this, but having an amplitude of 4, that means it's going to go up 4 units and down 4 units instead of just up 1 unit, down 1 unit. And I don't know why I went all the way out to 8 pi here. Let's just graph one period of the function. One period of the cosine. Remember, on cosine, what are your x-intercepts? Whole pies or half pies?
Half pies.
Half pies, so they still are. Half pi and 3/2 pi would be my x-intercepts. At my whole pies, the graph is going to go up to 4 and down to -4 and then back up to +4. It's that same U shape as our graph we have in the summary below, but it's just stretched with an amplitude of +4 rather than -4. Is that okay? Evan, is that okay?
Yeah.
Kelsey?
Yes.
Okay. The coefficient of the trig function affects the amplitude. The coefficient of the x affects the period. So what's the amplitude in the B part?
Is it 1?
Yeah, because that's the coefficient. But to find the period, you take the normal period and divide it by the coefficient of x. This graph, instead of having a period of 2 pi, it's only going to have a period of a half pi. It's going to do its whole thing in a distance of just half pi units. So between 0 and a half pi, it has to do its whole going up to +1, down to -1, and back up to +1. What's that low point going to be? What's the y value of that low point? No, I'm sorry. What's the x value? If this is pi over 2, the distance it takes for the graph to do its whole thing from +1 back to +1, where does it hit -1?
Pi over 4.
Yeah, whatever's halfway between 0 and pi over 2. Now, you could tell if we extended this graph and it's doing that whole thing every pi over 2 units, it goes from +1 to -1 back to +1, and then +1 down to -1 back to +1. You could see how tight that graph would be. That's because of the change in period. In the C part, what is the amplitude of that function?
1/4.
The coefficient of the trig function. And what's the period of this function?
2 pi.
Just the normal period divided by the coefficient of x, which is 1. So this graph is only going to go up to 1/4 and down to -1/4. And it's going to take the whole period of 2 pi to do that. In other words, its x-intercepts are still the half pi's. But at the whole pi, at the whole pi's, it's going to hit +1/4 and then -1/4 and then back to +1/4. Is that okay,
Yeah.
Miss Kelsey?
So on the line of 0, is it 1/4?
You mean the x-intercepts?
No, like the y. Like those dash lines, what is that value that you put on the dash lines? Is that 1 or is that 1/4?
Oh, my tick marks. You know what?
Yes.
It would help if I would label them. They were 1s, so
Okay.
it only goes up to 1/4 and down to -1/4.
Okay, that makes a lot more sense. I got it now.
Okay, unless I label my tick marks, I always mean -1 and +1. So,
All right.
but I could be more clear on that.
Oh, no,
All
you're
right.
good.
Okay, in the D part, what is the amplitude of this graph?
1.
Because the leading coefficient is 1. And how do you find the period of this graph? Tell me what math operation I would do to find that period.
2 pi divided by 1/4.
Perfect. And what is 2 pi divided by 1/4? And I'll love you forever if you don't have to pick up your calculator to answer that.
8 pi.
It would be what?
8 pi.
Yeah, because dividing by 1/4 is the same as multiplying by 4. 2 pi times 4 is 8 pi. It's going to take all the way from here to here for this graph to do its whole thing. Now, at its endpoints, sine is normally, or I'm sorry, cosine. At its endpoints, cosine is normally what? What's the y value at its endpoints?
1.
1. So that's not changed. The amplitude is still 1. I'm going to make at its endpoints, y is going to be 1. What's it going to be at its midpoint?
-1.
And where is the midpoint?
4 pi.
Yeah. What does that mean the x-intercepts are going to be? Where are the x-intercepts going to be?
Is it half pi's?
If it's +1 at 0 and -1 at 4 pi, it's supposed to have an x-intercept exactly in the middle of those two. What's exactly in the middle of 0 and 4 pi?
2 pi.
Yeah. And what's exactly in the middle of 4 pi and 8 pi?
6 pi.
Yep. See how stretched out that graph is? Because of the change in its period, it takes 8 pi radians, or 4 revolutions of the unit circle, to do its whole thing from +1 back to +1. All right, this last one, amplitude is absolute value, like distance, it's never negative. So when I say, what is the amplitude of this function? It's not -4, it's +4. And what's the period of that function?
2 pi.
The normal period divided by the coefficient of x, and the coefficient of x is just 1. So how does this look different than the A part, where the amplitude was 4 and the period was 2 pi? What do you think that negative coefficient does?
Flips it upside down.
Because that's the same thing a negative coefficient does to a parabola or any graph. It flips it, let me say it properly here, it reflects with respect to the x-axis, commonly known as flips it upside down. So it's going to look just like this graph flipped across the x-axis, where the graph normally would hit +1 at its endpoints. What's it going to hit here? At its end.
Negative.
0, -1, 2 pi, -1. And in the middle, it's going to hit +1. And my U shape is just upside down. My x-intercepts are half pi's. So do you understand amplitude and period pretty well?
Yes.
Okay, we've talked about everything but phase shift then. The things that you have to enter on the calculator, you have to tell the calculator or MyMathLab whether you're graphing sine or cosine. You have to enter the amplitude and the period and click a box if you want the graph to be reflected with respect to the x-axis. So what about this vertical shift and phase shift? What shifts the graph of a parabola vertically? Oh, I didn't mean y squared, just y equals x squared. What shifts a parabola vertically? What could I do to that equation if I wanted my parabola to be shifted down 4?
Subtract 4 from x.
Yeah, just subtract 4 after the function is applied. You would square the x and then subtract 4, and that would move your parabola vertically. Now, if you wanted to move your parabola, let's say, to the right 4, let's start with plain old x squared and tell me what equation would be the same graph but shifted to the right 4.
Would it be like y equals, in parentheses, x minus, did you say 5?
4.
What, 4 in parentheses?
Yeah, that is what does your horizontal shift. So just like always, adding or subtracting something after the function is applied is your vertical shift. Adding or subtracting something before the function is applied is your horizontal shift. And that same thing is true with trigonometric functions. So let's see, we only have about 10 minutes. Let's graph a few of, maybe a couple of those and a couple of those. In 4.1, let's say number 8. Now I'm doing this just a little bit differently than if we were going to graph it on paper and turn in our work. That's what I would prefer. But I'm going to make sure you understand how to graph these on my math lab. So first you're going to choose the function that looks like sine, which basically looks like that. Oh, I'm sorry, this was calculus up here. Sine goes up before it goes down and comes back up. So I'm going to choose that graph. And then what will I enter for the amplitude of the graph?
2.
Yep, the coefficient of sine. Excuse me. And what is the period of this graph? What do you look at to determine the period? The problems we just did?
You do 2 pi divided by x, or the coefficient of x.
The coefficient of x, yes. So the period of this graph is what? 2 pi divided by 1 is still 2 pi. Now, if we had a vertical shift, it would be something added after the sine is taken. So if I had sine of, in parentheses, x minus 2 plus 7, then my vertical shift would be 7. This one doesn't have a vertical shift. And then it's going to ask me for my phase shift. And that's where I made this note. You just set the argument of the function equal to 0, and that'll tell you how your graph has been shifted to the left or to the right. So if I set this x minus pi over 2 equal to 0, then I would get the phase shift is pi over 2. And that's what I would enter for the phase shift in my math lab, and it would automatically move the graph to the right pi over 2.
So for the phase shift, you'll put in pi over 2. You won't put
Correct.
the x minus pi over 2.
Correct. This is just how you find it, but you would say the phase shift is pi over 2. If this had been a parabola, y equals, let's say, x minus pi over 2 squared, you would have told me the graph had been shifted to the right pi over 2. That's what that phase shift is. This graph has been shifted pi over 2. Is that okay?
Yes.
Okay. What else did I say we were going to have to enter? That, where did I write that down? The amplitude, the period, the vertical shift, there is none, the phase shift, and is there a reflection here with respect to the x-axis?
No.
No. So as far as my math lab goes, if you just enter this information, it will give you the graph. If we were doing this on our own, on paper, we would say, this is what sine looks like. Our period is still 2 pi. So maybe I'll count by, let me just count by half pi's. Half pi, whole pi, 3/2 pi, 2 pi. On the normal period of, or the normal graph of sine, it starts with 0, 0, and it ends with 2 pi 0. Let me think. I'm having to think of both ways to explain it, the computer way and the on paper way. On the notes, what I had typed was to find one period of the graph. you set the argument between 0 and 2 pi, and you add pi over 2 to all three sides. That gives you the new endpoints of the period. The endpoints of this graph are going to be at pi over 2 and 5/2 pi. The y's are still 0 because this graph hasn't been shifted up or down. It's just been shifted to the right. So it's going to have an x-intercept in the middle as well. And then between its x-intercept, this is the shape that we need to put in. The graph will go up to how far? What's the high y value on the graph?
2.
Yeah, instead of 1, it's 2. And halfway between these intercepts, it will go down to -2. Now my math lab's going to do that work for me when I enter all of this information. But if I were graphing it on paper myself, I would still list the amplitude, the period. I don't normally talk about phase shift. I just say set the argument between the normal endpoints and then attach this shape. Is that okay?
Yes.
Yay. All right. The next one I had circled. Ooh, 14's good. Wow, this has every possible thing you could do to a graph. What does this negative coefficient tell me?
We have a reflection.
All right, so I would check that box if I'm doing it. I have my phone set. Are y'all okay with doing a couple more examples? Even though we only have 5 more minutes, I'd like to make sure you're okay with this, especially since I don't have this video until on YouTube. That be okay?
Yeah, that's fine.
Yes.
Okay, y'all can just log out whenever you want to leave. So we have a reflection with respect to the x-axis. What is this -1 do to our graph?
Vertical.
Yep. Actually, in my math lab, there's a little slider scale, and you'll pull the slider scale over to the left one. What's the amplitude of this graph?
1.
Yep, because the coefficient of sine is -1, only amplitude's never negative. For a phase shift, tell me how I'll find that phase shift.
Would you say 3x plus pi equals 0?
Mm-hmm. Which you're probably only going to have to write down about 1 time before you get used to looking at it and saying that phase shift is what?
-pi/3.
Okay, so I'm not even going to write this equation down anymore. I'm just going to say the phase shift is -pi/3. And then I believe I left out the period of this graph. Tell me how to find the period of this graph.
Would you say 2 pi divided by 3?
The normal period divided by the coefficient of x. So 2/3 pi. And if you have entered all of that on the calculator and you have chosen the graph that looks like 1 period of sine, then in my math lab, you'd be through. But if you were doing this on paper, you would say 1 period of the graph, actually the endpoints of 1 period, are found by setting the argument between the normal endpoints for 1 period of sine, and you'd solve that inequality. You would subtract pi from all 3 sides, and you would divide all 3 sides by 3. And there's a nice built-in check here. What's the distance from negative pi over 3 to pi over 3? How many units is that? If you're counting from negative 1/3 to positive 1/3. Or if you subtract the left endpoint from the right endpoint, what's pi over 3 minus negative pi over 3? Somebody say 2/3 pi.
2/3 pi.
Yeah, 1/3 minus negative 1/3 is 2/3. That's the length of 1 period, and that matches what we said right here. So it's just kind of a nice built-in check. If that period turns out to be the length of that interval, then I feel pretty good about the way I've solved the inequality. So I'm going to say the endpoints, instead of being at 0 and 2 pi like they normally are, they're at negative pi over 3 and positive pi over 3. And now all I have to do is find those 2 y values. What is sine? What's the y value of sine? Something's bugging me. What's bugging me? Oh, I was just saying what to punch or what button to click in My Labs Plus, but it actually looks more like this. What is sine normally at its endpoints? The y value at its endpoints.
0, 0.
Okay.
Pi 0.
Yeah, 0, 0, 0, and 2 pi 0. So the endpoints are normally 0, except for in this graph, they've been shifted how?
To the left one.
I should have said vertically. Vertically how?
Down one.
Okay, so instead of these being 0, they're going to be what?
-1.
-1, except for one other thing to watch out for, where this graph would be hitting -1 because of the negative, because of the flip. These are going to hit what? You know what? Okay, play like I didn't just say that. Let me start over. In the order of operations, you would take the normal endpoint and then flip it before you subtracted 1. I was doing that backwards. So if we took 0 and flipped it across the x-axis, what would y be? It would still be 0. And then if we shifted that down 1, it would be -1. So those are our endpoints of 1 period. Our midpoint is what's halfway between negative pi over 3 and positive pi over 3. That's 0. And normally at its midpoint, sine would be 0. So shift that down 1, and it's at negative 1. I didn't do my very best explaining on that one. That's why I want to do one more. Y'all are going to like graphing this in my math lab. But let me see if I can get this. From negative pi over 3 to positive pi over 3. Instead of hitting 0, instead of hitting 0 at its endpoints and midpoint, it's going to hit negative 1 at its endpoint and midpoint. Then if you just say, normally sine goes up before it goes down, just make this one go down 1 before it goes up 1. This definitely takes practice. In calculus, it is very important that you have the basic graph of trigonometric functions in your head so that you can do the other things we have to do in calculus. I'm not expecting that made 100% sense the first time, especially since I made a mistake in explaining it. But if you look back at it, I think with practice, you'll be okay on that. And I want to do just one more, number 28. I want to do one that has cosine in it. And this one is ugly in that it has a reflection and a phase shift. It doesn't have a vertical shift. The negative tells me the graph is reflected with respect to the x-axis. I know that the normal graph of cosine, as long as I'm using 0 to 2 pi, it looks like that. So that's the button I'm going to click in my math lab. What is the amplitude of this graph?
Four.
Yep. So instead of hitting positive 1 and negative 1 at its endpoints, it's going to hit positive 4 and negative 4. Well, it's going to hit positive 4 at the endpoints and negative 4 at the midpoint, except for this has been flipped upside down. What, excuse me, what is the period of this graph?
Would it just be pi? Pi divided by 2.
Normal period divided by the coefficient of x. And then I think the only other thing we're going to have to tell my math lab is the phase shift. What will you enter for the phase shift?
You would say 2x plus pi over 3 equals 0.
Okay, and then do what? To solve that equation for x, what's the first thing you would do?
Subtract pi over 3 to both sides.
And then?
Divide by 2.
So what would you get for the phase shift?
Negative 2 pi over 3.
Let me write it down for you. 2x plus pi over 3 equals 0. So 2x is negative pi over 3. I'm not multiplying both sides by 2. I'm dividing both sides by 2. What's 1/3 divided by 2?
Negative pi over 6.
Yeah, negative pi over 6. Is that okay, Miss Kelsey?
Yes.
Okay. So I'll enter negative pi over 6 for the phase shift and make sure I have the reflected box clicked and choose the right graph. And that's all I'll have to tell my math lab. You'll love it. But if we weren't quarantined right here, we'd say to find the endpoints of one period, we would set that 2x plus pi over 3 between the normal endpoints of one period of cosine. And we'd solve that for x. We would subtract pi over 3 from both sides. Oops, typo. Supposed to be 5/3. 6/3 minus 1/3 is 5/3. And then divide all three sides by 2. See, that phase shift is just where your left endpoint has moved to. The whole graph has moved pi over 6 units to the left. And so the endpoints of one period occur at negative pi over 6 and 5/6 pi. And what's halfway between? How do you even find, if God doesn't whisper to you, how do you find what's halfway between two numbers?
Divide by 2.
Add them and then divide by 2. If you add those, you would get 4/6. Divide by 2, you get 2/6 that are known as pi over 3. Now, normally, what does cosine hit at its endpoints? What are these y values at its endpoints? Look at your cosine of 0 is what?
1.
And cosine of 2 pi is also 1. So normally at its endpoints, cosine hits 1, but this has been flipped and multiplied by 4. So where it would normally hit 1, it's going to hit what?
Negative 4.
And where it would normally hit negative 1, it's going to hit what?
Positive 4.
Positive 4. Now I can count by anything I want, but since I want to graph negative pi over 6 and positive 5/6 pi, kind of makes sense that I'd count by sixths. Negative 1/6 and then 0, positive 1/6, 2/6 is a third, 3/6 is a half, 4/6 is 2/3, and then 5/6 will be my right endpoint. Make it easy on yourself by labeling or counting and labeling your tick marks by whatever you want. So the endpoints are going to be at negative pi over 6, negative 4, positive pi over 6, negative 4, and the endpoint's going to be at pi over 3, positive 4. And if I connect that the way that I know that cosine is supposed to look when it's flipped upside down, that's what my math lab will do for me. Just a few double checks. Does that look like the graph of cosine flipped upside down like we knew it was supposed to be?
Yes.
Is the amplitude 4 like we knew it was supposed to be?
Yes.
Is the period pi like we knew it was supposed to be? If I subtract 5/6 pi minus negative 1/6 pi, that's 5/6 pi plus 1/6 pi, that's 6/6 pi, also known as 1 pi. And it is shifted pi over 6 units to the left. All right, is that enough to get you started on the homework?
Yes.
All righty. If you get stuck on anything tonight, just take a picture of how far you got before you got stuck. Click the help me solve this in viewer example. I believe they're only available in review mode. So if you miss one, go to your grade book, click review, and then help me solve this so it can work you through the problem one step at a time. If you still don't get it, email me, okay?
Alrighty.
Okay, thanks for giving me a few extra minutes. Y'all have a good day.
You too, Miss Miles. Thank you.
You're welcome. Bye-bye.